Good day everyone, I'm Nathan Fenomeno and today I will be discussing my exponential function that I created for my part or my contribution in the story. This function first appeared in the scene where the news was being flashed in the TV, and as the news anchor was discussing the recent breakout of the new Among virus. This Among virus really took the story for a turn along the entire video, which I hope you've watched. We can see that in the situation of the story, it describes the function as a virus that grows 5% in quantity with every passing hour. In this situation, the scientists are currently trying to figure out how big a laboratory sample of this virus will spread to accurately predict the future trajectory eventually when actual results are published. So basically, this is just a proof of concept by the laboratory scientists who were trying to figure out how much it would grow after one day. The term or the situation started with an initial sample of 10 CFUs, with the term CFU referring to the measurement of bacteria in a sample. CFU stands for colony forming units. That's it. And in this certain situation, the x-axis refers to the time elapsed, the hours elapsed, while the y-axis will refer to the amount of CFUs after that specific x value. So now we can proceed. In regards to the structure of the structure and general characteristics of this function, we can see that in this function, it exhibits exponential growth as it is pointing upwards. It is exhibiting exponential growth and not exponential decay, as we can see that the 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 variable b in the equation y is equal to a b to the power of x, b is greater than 1. And if it is greater than 1, then it should exhibit exponential growth. Additionally, we can also see that in this function, we have a coefficient of 10, with this coefficient also means a translation of 10 upwards. This means comparing it to a regular function, it would be translated, well, yeah, 10 upwards. Oh, and by the way, it is to be noted that only positive and zero values will be considered in the context of this illustration. So, based on that, it inherently changes our domain and range. Now, with our boundaries established, we can actually now just accurately determine our domain and range. For our domain, we can see that it stems from 0 until positive infinity. Additionally, our range also now stems from 10 until positive infinity, based on the specific measurements that we had to take to properly illustrate this in the context of the story. Now, we can oh yeah, we can now proceed to the additional metrics on how more we can describe this function. We can of course see that if we perform a vertical line test, we actually can already figure out that it is a function. Well, we already established that it was a function. But now, the question is it a one-to-one function? So, as well, if we try it right here with the horizontal line test, it we can really see that it is a one-to-one function. So, if it is a one-to-one function, and if it is a function, we can inherently predict that this function will have an inverse. Additionally, if we think about symmetry, it's not inherently symmetric to itself, but it will be symmetric to its inverse along the axis of x is equal to y. Yeah. Additionally, or lastly, actually, one of the last things we'll be talking about would be their x and y intercepts. Inherently, if it's an exponential function, well, if it's a standard exponential function, or especially in the context of this, we don't really have an x-intercept as it, even if we remove the boundary, even if we extended the domain from negative infinity to positive infinity, we would still have no x-intercept because yeah, it really is just set to never touch zero in yeah, it's never really set to touch the x-axis, therefore never really having an x-intercept. Additionally, we can see that our y-intercept is presented right here. Y-intercept presented right here at the value of 10. Basically, the y-intercept is now 10. So yeah, to conclude, I guess let's try to solve our sample problem based on our sample function. If the virus grows 5% bigger every hour and the scientists are trying to figure out how big the sample would grow after a day, what we first have to do is figure out how much hours that there are in a day. So one day having 24 hours. With this, we can now accurately substitute the amount of hours to the x value in our function. So with this, we can see that in the function f of x is equal to 10 to the or to 10 times the quantity of 1.05 to the power of x, we can see that with f of x, with x being 24, it inherently just becomes 10 times the quantity of 1.05 to the power of 24. And if we will calculate it and input it in the calculator, we will get an estimate of 32.25 CFUs. So now if we try to look at this in the graph, with x being 24, which is just above here, then scrolling up around there, we can see that the point that it reaches is really just above 32, accurately displaying that if our x value is 24, signifying 24 hours, the virus would have grown to a size of 32.25 CFUs from its original 10 CFUs. So, yeah, basically, this function was really influential in duration of the duration of the story because it illustrated the lab test sample that really paved the way for the Among Us virus, which turned the course of the story for the worse. But if it wasn't for this, we wouldn't have had such an interesting and lovely and inspiring story. Basically, this function was aired on the news as a means to warn people as a proof of concept. As this graph, well, basically showed the rate of how CFUs grew in a span of one day. I'm Nathaniel Fenomeno, and thank you for listening.